Well, you know, life is hard sometimes, right? All right, so let's take a look at this. I don't want you to stress about this, but I do want you to be familiar with this and understand how to deal with these problems. So let's take a look at question 1. First of all, on a scale of 1 to 5, 1 being I looked at the graph and I had no idea what to do, and 5 being I totally understand this 100%. Let's just move on. Where did you all lie on this? Can you give me a 5, 4, 3, 2, 1?
4.5.
4.5, like that?
Yeah. 4.3.
Like I just want to make sure the answers are right, kind of a thing, or like a. All right. So let's talk it through and let's see how we do. And then if we need more time and help with it, we can. So number 1, part A said, is the acceleration greater between 2 and 3 seconds or 5 and 6 seconds? What'd you guys say? 5 and 6. Why? Yeah. I'm just going to write that down. You might want to write that down just so that if you're looking at this again, you remember, right? Because when you're studying for a test, you may not have this conversation in your memory bank super well. So it has a greater slope. Just a friendly reminder of what to look for. During what time interval is the acceleration 0? What'd you say? Awesome. How do you know? What's that? Horizontal slope. Yeah, slope is 0. Yeah. All right. What is the displacement between 5 and 6 seconds? So we need to pay attention to what kind of graph this is. I didn't actually mention that before. It's a velocity graph, right? Velocity versus time. How do we find the displacement between 5 and 6 seconds? We do the area, yes. So I'm going to draw a line here for 5 seconds, a line here for 6 seconds. We're going to either pull out our mad geometry skills and say, ooh, what's that shape? Come on, geometry friends. Starts with a T.
It's a trapezoid.
It is a trapezoid. So you can either remember. So here's the thing. Here we go. So I want to tell you. I'm gonna give you the secret, like the secret back door to the geometry world, right? You can either use your area of a trapezoid, which is base 1 plus base 2 divided by 2 times the height, right? Divided by 2, like that. That's how you do that, right? It's awesome. I can drive it for you, but not right now, okay? Or you can recognize that a trapezoid in this case really is what? It's a rectangle and a triangle. So you can totally do that as well. Either way is fine. Did anybody get an answer for that? No, for the whole thing. The area of the trapezoid?
Well, let's do the triangle is 5 times 5.
Divided by 2?
Divided by 2.
Okay.
So that's 12.5 for the triangle.
Oh, you know what though? Hold on. You're right. You only knew the triangle. I didn't read it carefully. The displacement between 5 and 6 seconds is just the triangle because the other stuff is the displacement from the origin. Right? Is that right? No, hold on. No, that's not right. I'm sorry. I misspoke. No, you need the whole thing. You need the whole thing, the whole business.
Why would you only do
It's not 5 by 5. You were lying to me. Lies! How many seconds is this?
1 second?
1 second. Okay, let's do this right. Let's go through this. So the area of the triangle. So it's going to be 1/2. The base is 1. The height is 5. Yeah? Is that okay? Because the top, look up here. I want to make sure this makes sense. There are 5 little boxes, but you have to look at the scale, don't you? What's the size here?
That's 1 second.
It's 1 second. And you go up 1, 2, 3, 4, 5.
That's different units though.
But you have to go by the scale. You have to go by the scale. That's the rule. That's why you always have to pay attention to how things are labeled. Right? Because otherwise, if you're finding slopes, if you just go by the boxes, then this is always going to be the same thing. Whereas if this was stretched down, like if this was like 1, 2, 3, 4, 5, 6, 7, 8, it's a different slope. Right? Slopes are definitely dependent on what the axes say. So we okay with the area of the triangle being 2.5? Let's find the area of the rectangle. Area of the rectangle is 1 times 5. Is that right? No, not 1 times 5. 1 times, how high does it go? 10? I can do that in my head too. I love math. I can do it in my head. That's 10. What's the total area?
I have a question. Where
Go.
did you get 1/2 from again?
For this part here?
Yeah.
Because I'm finding the area of a triangle.
Oh,
1/2 base times height. Is that okay?
yeah.
Okay. Please, thank you for asking that question. Please ask those questions, because sometimes I just go through fast because I'm just assuming, oh, yeah, you're all in my brain, but you're not. Are you? You're in your own brains. So let me know if something doesn't make sense. Yeah.
I know that it's wrong to do, but if you only take the triangle, the 5 units on the bottom.
You got lucky.
Yeah, you get 12.
You got lucky.
I know.
There's no like.
There's no reason for, well, the reason for it is that these are by 5s and there are 5 units. That it's just pure luck. So there's no like secret. There's no secret in there. And honestly, I will tell you that that's why I would never give you a test that just asks you for an answer. Because the reason I was like, oh yeah, that's all you need to do is because I had 12.5 written down. They're like, oh yeah, you got it. Oh wait. You got the right answer for the wrong reason. And in physics, the reason is more important than the answer. You with me there? Yeah. Okay. So the answer there is 12.5. 12.5 what? Meters. All right, how about D? How do you do D? What is the acceleration between 5 and 6 seconds? You have a velocity versus time graph. You're looking for the acceleration. If I have a velocity versus time graph, and I'm looking for the acceleration, what do I look at? The slope. Just have to calculate the slope. Can you calculate the slope? Well, yes, I can. Sure. Right? You can do this. Rise over run, friends. So we go up 5. Well, we go over 1. Is that okay? Rise over run. 5 meters per second divided by 1 second. That's 5. Have we talked about these units yet? I don't know. Welcome to units time. Meters per second squared. 5 meters per second squared. What is the displacement between 3 and 4 seconds? Okay, so we have to think, right? This always requires us to think, which is kind of annoying. Jeez. We got velocity, time graph. We want to find the displacement. What are we looking for? What are we going to do? We're going to do an area. Velocity to a displacement. We're going to look for the area under the curve. You can do it between 3 and 4 seconds. If you haven't done it already, go ahead and do it right now. Between 3 and 4 seconds. It's this thing right here. I can find the area of that thing, right? Base is 1. Height is 10. 1 times 10 is 10. 10 what? 10 meters. How are we doing? Doing okay? All right. Do you want another moment to talk about number 2 with your partners, or you just want to keep going? Keep on rolling? Sweet. Let's go. I have a different number of questions than you because you did not have the question that looks like C, I think, right? Or did you? No, you did. Okay, good. All right, cool. I took one out at some point, but there must have been an F. All right. What is the velocity between 20 and 25 seconds? How do you find that out? This is position time, so this is displacement time graph. How do you find the velocity? Distance divided by time? Or the what of the graph? Slope of the graph? From between 20 and 25 seconds? That's here. What's the slope of the graph? 0. Holy cow, this is super frustrating. Is the velocity greater between 0 and 5 seconds or between 10 and 12 seconds? What am I looking at? What part of the graph am I looking at? Between 0 and 5 seconds. So here's 0 to 5 seconds. Here's 10 to 12 seconds. In which case am I going faster? 10 to 12. What is it that you're looking at? The slope. But you can do it. You can see that this is steeper. I'm not asking what the value is. All I'm asking is which one's steeper. And you can tell which one's steeper. No, it is accurate. That's absolutely accurate. I'm not asking you for a value. If you needed a value, then you'd have to do calculus, and I'm not asking you to do that. All I'm asking you to do is you can see that this curves, and if it curves, this slope has to be higher than this slope, right? Because the slope keeps getting steeper and steeper and steeper because it's a curve.
That's our evidence.
That's it, right? The slope is greater here than it is here. That's it. Yep, that is your evidence. What is the velocity between 15 and 20 seconds? What are you going to look at there? Nope. Between 15 and 20 seconds, so that's here during this time. So we can look at rise over run, change in y, I can't tell what that is, 45, 50, it goes up by threes, 48, 49, 50, so that's 51 to 60. That's annoying. So that's 9, up 9 while it goes over 5, 9/5, so like 1.8. Oops, not squared, just plain old. How are we doing? Are we okay? Is this making sense? Do you get kind of the pattern that's happening here? You guys are going to be experts at this in no time. During what time interval does the object accelerate? Where do you think the object's accelerating? What do you think, Ryan? When is it accelerating?
From 0 to 20 seconds.
0 to 20 seconds. Why do you think?
Because the slope is going up.
Slope is going up, up, up. So here, yeah, this part's debatable. I think it looks like it's curved too, but at least from here up to there. Is it accelerating during this time? Hard to remember. I don't remember. Let's look at our graph sheet that we made, that handy dandy graph sheet. The acceleration is 0 in both of these cases. The only time that you're going to have an acceleration is if you've got a curved displacement. A curved displacement means that you have a changing velocity, and a changing velocity means that you have an acceleration. Okay, that might be a good thing to write down. A curved displacement means that you have an acceleration. Okay, if your displacement graph is straight, either at an angle or with a 0 slope, no acceleration. So I'm going to guess between 5 and, what is that, 12? Oh, thank you. Awesome. Holy cow. What? All right, last one. E. What is the displacement between 15 and 20 seconds? How do you figure that out? That's the easiest one of the whole bunch, isn't it? Yeah, you just look at it.
And we already found that slope.
Yeah, between 15 and 20 seconds. Is that what we did over here?
For C, yeah.
Yeah, so it's just 9. Is that right? Well, that's convenient. All right. How we doing? We doing okay? Cool. All right. Let's see. We've got a few minutes left. I just want to see where we're at here. Okay. You're going to have a really short homework assignment, but that'll be okay. Oh, no, it'll be okay. We got some. All right. On someday, I don't remember when this was, when we filled this out, we wrote this equation out, didn't we? We found this from this. We were just finding the slope. I just want to articulate this a little bit more so that you've got it written down. So I'm going to ask you to get out a fresh sheet of paper today or right now for your notes that we're going to add to tomorrow. But I know that I'm going to want you to have it on one piece of paper. So go ahead and get out a fresh sheet of paper right now. I'm going to get out a fresh sheet of paper as well. Okay? And we're going to write down acceleration equations. Acceleration equation, there are going to be 4 of them. This is when today and tomorrow you're going to be like, oh, that's why you wanted me to use the guess method. That's why you wanted me to write out those givens. There's a reason for it, and it's going to happen tomorrow, but it's going to start today. Acceleration equation number 1. Here it comes. Okay? You figured it out a couple days ago. We just didn't write it down. We wrote it as A equals delta V over T. What does delta mean? It change in position. It means delta X is change in position. So the delta means the change between the final and the initial. So V final minus V initial, and then I'm going to divide by time. Okay? So taking away this middle part, this is the equation that you really want. You can also do some fancy algebra if you don't like denominators to write this as V final is equal to V initial plus AT. So if that makes you a happier person, you can use that. Okay? This is the equation that you're going to use on your homework today. And I'm going to give you a problem to start, and then I'll give you some homework as well. Does that make sense? I'll tell you what the homework is going to be for tomorrow. So that's all you're going to write down on your new fancy piece of paper that you have. So we're going to work on some problems. Don't put stuff away, but just leave some space because you're going to have like half a piece of paper full of this stuff. So here is a question that I want you to try using that equation. Let's do just one of these together. A car traveling 7 meters per second accelerates at, oh my gosh, that's a little typo. That should be a 2, not an S. At 0.8 meters per second squared for a time interval of 2 seconds. It says find the car's final velocity. Okay, so we're going to write our givens down pretty fast here. I'm just going to do this fast because I want to make sure that we have a chance to do the problem. So it starts out at 7, so that's going to be our initial velocity. It says it accelerates, so that's going to be my acceleration for a time interval of 2 seconds. And then it says find the final velocity. That's the G and the U in the guess method right there. Going fast because I want to watch out for that bell that's going to ring. The equation that I'm going to use, I usually write it out like this because this is how it's always been stuck in my head. Okay, that's how I've been trained to use it.
So, yeah. Well, final velocity
Is your unknown, exactly. And usually you can find it at the end of the sentence or at the end of the problem, right? Find the car's final velocity. So that's what you want to know. So then I can multiply by T on both sides. I'm going fast, I know, but you guys can watch this again. Work on it. We'll practice it tomorrow a lot. The T's are going to go away. And then I'm going to add. So I've got A times T equals VF minus VI. I'm going to add a VI to both sides. Is that okay? Then I can plug in my numbers. So I've got 7 meters per second. Make sure that you include your units. We'll talk about why tomorrow. It'll make your life a much happier time. I promise. Times 2 seconds. And that's going to be your VF. Are we okay so far? Here are the problems that I want you to work on for tomorrow. I'm just going to write them down over here. So this is your homework for Wednesday. Make sure you write this down because it's not this way on Canvas right now, but I'll change it. Page 57, number 1, and number 3, part A. page 75, number 21A, and number 16. Okay? So parts B and C for these two ones that I just said, part A, are things that we haven't learned yet. You can absolutely read the book and absolutely figure it out. And we will do it for Friday, or excuse me, for Thursday. But this is what I want you to work on for tomorrow. Sound good? Happy Tuesday, friends.
Have a good day.